Hello there, it's Lagaya from Boost Revision and welcome to this live revision clinic on exam technique, tips and tricks. So some of you may have already had some mocks recently in January. Some of you may still have them coming up around half term in February. And perhaps you've done a lot of revision and you think you know the topics, but you come to the exam and you're not really sure how to get what you know in your head down onto paper. Or maybe you've seen in your reports or teachers write things like you need to improve exam technique, need to be more precise, things like that. So I wanted to go through a few little tips and tricks today, advice on how to approach your exams to help you to translate what you know in your head onto a piece of paper in the exam and make sure that you get the maximum marks possible. It might surprise some of you that, I think you probably heard me say before that you need to practice doing past papers as much as possible. And I definitely know I've had a lot of students in the past who've been surprised by how easy it is to lose marks by just not really paying enough attention to things like the command words in questions and checking their answers and losing marks where they needn't lose marks if they just checked their answers and things like that. So I'm going to share my screen with you so you can see what I'm going through step by step. We're going to go through some main points for exam tips and techniques, and I'll give you some examples of some of them as well. So hopefully you'll get a good idea of what I mean by them as we go through. So if you're watching this live on YouTube, then please feel free to put any questions you have in the chat. I'll keep an eye on that as the live progresses. And if you're watching this on Zoom, the same thing goes for you. There's a chat box in the Zoom window that you should be able to use to actually ask questions to me. And you can choose whether you ask them just to me or to the whole group. So please do ask questions. It will make it much more useful for you if you ask the questions that you have as we go through. So these are the main things I'm going to go through, the main things I'd like you to think about when you're approaching your exams. The first thing is planning your time. So for example, if you're on OCR and you're looking at AS paper 1, you're allocated an hour and 30 minutes for that whole exam. In the first section, which is multiple choice, it actually indicates on the paper not to spend more than 25 minutes on that multiple choice section. There are 20 questions, which means that you have, I've written less than a minute, but you've got just over a minute for each question. If you had 20 minutes for 20 questions, obviously that's 1 minute per question, so you've got 25 minutes, which gives you about 5 minutes to check your answers at the end, or just a little bit longer than a minute per question. And just keep that in mind as you're going through to make sure you keep on track. And if you get to 25 minutes and you haven't finished those 20 questions, then I would recommend you keep going on to the next section and just leave some of those questions blank for now, because the questions that come later in the paper are going to be worth more marks, and it's better that you spend longer on those perhaps longer answer questions or the questions that are worth more marks, so that if you were to run out of time, you're maximizing the amount of marks that you can get. In the second part of the paper, you've got an hour and 5 minutes you've got an hour for 5 long questions, which makes about 12 minutes per question. So again, all the questions will be different, and perhaps some you'll finish more quickly and some will be more slow. But I would try to keep in mind that approximately 12 minutes per question. So keep an eye on the time as you're turning the pages. And when you get to a new question, then try to aim for about 10 minutes and then a couple minutes to check the question afterwards. If you know that you're going to be much faster at the calculation questions, then perhaps you can spend 15 minutes on a longer written question, but just try to keep that average time in your mind. And so I allocated an hour for that second section so that we've got 5 minutes left at the end of the paper that you can use to check all of your answers and tidy things up at the end. Your examiner is going to find it much easier to mark the exam if you've got if he can see clearly what he's trying to, or he or she is trying to mark. If you've made some mistakes, make sure that's crossed out really clearly so that they don't mark your wrong answers. if you have crossed something out, but you haven't written a replacement, then if they can still read it, they are obliged to read that answer that you've crossed out. But if you're sure it's wrong, then I would recommend writing a replacement so that they mark what you think is actually the answer that you want to do. So use that 5 minutes that you've left at the end to check through all of your work and tidy up any answers that perhaps you might have crossed out and made some mistakes in, just to make it really clear what the examiner wants to look at for marking. Just as another example, in the second paper for AS chemistry on OCR, that's depth in chemistry, you get an hour and 30 minutes for that. And that's all long questions, so about 7 questions depending on the paper, which gives you again about 12 to 13 minutes per question. So if you're someone who's good at calculations, maybe you'll do those much quicker, and that will allow you more time, more minutes to do the long answer, less structured questions. Or perhaps it's the other way around. Perhaps you're not very good at calculations and you need to check those answers again and again. Perhaps you need to use the data booklet a lot, which might slow you down. But then if that's the case, then hopefully that means you can try and get through your longer answer questions a little bit more swiftly, perhaps by answering in not necessarily just bullet points, but just much more of a concise way when you're answering your written question. So try to, as you go through the course and you do your tests at the end of each topic at school, and you do your practice papers and mock papers, try to get a feel for what sorts of questions take you the longest amount of time, and just keep in mind the amount of time that you're spending on those questions in the exam, and plan your time accordingly so that you don't run out of time at the end. So the second tip here is to reread questions. So that might seem a little bit of overkill to some of you, but this is basically because it's really, really common for students to misread questions if you just read it once and get straight down to an answer. So I recommend reading the question at least twice, if not 3 times, before you actually put your pen to paper and try to answer that question. So, you know, often the question might be, why do you see this trend in, for example, reactivity of group 2 metals? Or perhaps you might have read this or read it the other way around, like, why don't you see this trend or something? So it might sound silly, but it is very, very common for students to misread questions and get the wrong end of the stick. So try to make sure that you reread the question and make it really clear to yourself what the question is asking, so that you're really clear that when you're writing words down on the paper, that those words are actually answering the question that's been asked. Another really common thing to do is to learn just like set answers from mark schemes, and sometimes that can be effective, but often what will happen is you're using a set answer that will actually not be directly answering the question you've been asked, and that will obviously not end up getting you the marks that you need. The next thing I would suggest, and I really suggest this strongly, is to highlight key information in the question. So you can do this with an actual highlighter, or you can just use your pen or pencil and underline the keywords in the question. I think this is an example of how I've done this for a calculation question. So with this question, as I approached it, I read the question first of all, and then I went back and I used my highlighter to actually highlight the key parts of the question. So here I've used different colors for the different substances in the question, and that also additionally helps me to identify the different solutions that are in the topic. So for example, sodium sulfate Na2SO4 is one of our products, and then we've got the pink stuff, H2SO4 sulfuric acid. I've highlighted those in pink and also outlined the part of the equation in pink, so that I know that everything that's pink in my highlighting or in my annotations on the question is all to do with the sulfuric acid. Equally, the blue highlighter and the blue lines here I've used to talk about everything that's NaOH, so that's our sodium hydroxide. And again, this helps to, when you're going through the calculations, it helps you to refer back to the question and be really clear what information is relevant to what pieces of, what parts of your chemical equation. So you may not want to use different colors. Everyone has their own way of working. For me, I'm quite visual and I really like using colors, and for me it helps to make sure that I'm not misreading information and confusing what information is for the different chemicals as I go through. again, then the actual question part is this part here where it says calculate the minimum volume of H2SO4 that the student would need to completely react with the NaOH present. So you've got the information above and then the actual question. Another common mistake I see a lot of students making is just going straight for the question and completely ignoring all of the information that they've been given up in this top section here. And of course, that's going to mean that they get a bit confused. They don't know where the pieces of information are that they need to put into the calculations. And of course, then you're more likely to get lost. So if I was approaching this question, as I said before, I would read it once all the way through, make it clear what it is that's being looked for the answer. Then I would go back and I would highlight the key information in the question. So the information about volumes and concentrations, the information about the chemical equation. And I may even then read it one more time before I actually start putting pen to paper. More likely what I would do is I would actually start after the second reading, and then before I write my answer, I would go back to the question again to just make sure that I've answered it as according to what the question is asking. Often you'll find that they give you the units for calculation questions like this, but sometimes that's not the case, especially later on in chemistry, when you learn about rate equations and equilibrium constants, they often ask you to calculate the units too. So there's often a space for both the value and the units, and it's important that you fill out both of those spaces and make sure you're giving all the information that's been asked for. So highlight key information. It really helps you to focus on what you need to write, not just the answer, but perhaps what steps you may need to go through in the question. The next point is to know your command words. So depending on your board, the board itself may have specified specific meanings for command words. So I know, for example, AQA publish a whole list of the command words they use and exactly what they mean by that. But just as an example that perhaps many of you will be familiar with, common ones would be state, describe, explain, deduce, calculate. So not only do these command words actually give you a really good clue as to what they're looking for your answer, but they'll also give you an indication of how much detail to include. So for example, state will normally just mean name something. What is the thing that the question is asking about? Describe, this may be for something like observations, and you want to just say what you see. That's what describe is saying. Explain is obviously explaining something. So if you see a certain trend, perhaps the question says describe and explain. That means you'd get probably 1 mark for describing and perhaps 2 marks for explaining what you've just described, that observation. So the explanation would be, I see this observation because, you know, something, depending on what the question was, you might say there are more electrons in the outer shell, or, you know, there's the same number of shells and lower atomic radius. So you need to give reasons to back up what you've just observed. Deduce and calculate are usually used in calculation questions, but calculate means you're likely to actually need to put some stuff into an equation and do something on your calculator. Whereas deduce is often some kind of deduction based on moles equations in the calculation. So for example, in a titration calculation, you may be expected to calculate the number of moles of an acid you have from a volume and concentration. From that, you can deduce how much of the alkali you had if you know what the balanced symbol equation is. So if you had a 1-to-1 ratio and you calculated we have 5 moles of acid, then you can deduce that there are 5 moles of alkali too. So it's sort of related to calculations, but deducing normally does not require you to do any further calculation. It normally requires you to do something to do with moles ratios, proportions, that kind of thing. Okay, the next bit is to plan your long answers. So that kind of speaks for itself, really. Often you'll have 4, 5 or 6 mark answers, and there's plenty of space given to you to actually fill out that space. But what I've often found with students I work with is that they start feeling quite clear about where to start, and then halfway through their answer, they kind of forget what the question was, and they kind of start just regurgitating things that they learned in the lesson about whatever it was they started with. So I would suggest that before you start writing a long answer, you actually sketch out a plan. I think I have an example of this over here. Yeah, so this is a 5 mark question about saturated hydrocarbons, and you've been given 3 different isomers and 3 different boiling points. Compounds A, B, and C are all saturated hydrocarbons, and we've been given the structures of each. Then it says use the structures to explain what is meant by the term structural isomer. Okay, so that's explaining what is meant by that, and we want to use the structures. And then explain the trend in boiling points shown by the table. So if I was planning this out and writing what how I'm going to plan out my answer, I'm going to think, okay, how can I use the structures to explain the term structural isomer? You want to first define the term structural isomer, and use the structures to explain how they match this definition of a structural isomer. So a structural isomer are molecules that have the same molecular formula but different structural formula, which means that the molecules have been moved around in the structure. So you can use those structures to show, for example, that these are all the same, they all have the same molecular formula. 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5 carbons. So these are all going to have the same molecular formula of C5H12, but they all have different structures. A is a straight chain, B has 1 branch chain, and C has 2 branched chains, or a methyl group has 2 methyl groups, or however you want to explain it. You want to link the structures that are shown to the definition of your structural isomer. So you would define the structural isomer, state that they all have the same molecular formula but different structural formulas. Then the second part says explain the trend and boiling point shown. So the first thing before you explain is to actually state what the trend is. You can see this arrow going up here. You can either say as you go up, so as the chains get straighter, the boiling points increase, or you can go down. As long as you're really clear about what direction the trend is going, then that will be fine. So you're going to say how the structures relate to the differences in boiling points. What is the trend that you see? And as you're going down, what you're seeing is the more branches there are, the lower the boiling point. But then it wants you to explain that. So you're explaining that in terms of linking the boiling point with the amount of London forces or van der Waals forces and the amount of energy that's needed to break those bonds. Because whenever you're talking about boiling points, explaining boiling or melting points, you want to link the amount of energy that's needed to break bonds to the type of bond and the boiling point. So trend in boiling points go down as you have an increased amount of branching. And this is because the London forces are interrupted, because the molecules can't get as close to each other or stack as close to each other as they can in a straight chain. So less energy is going to be needed to break apart the branch chains than the straight chains. The more branching, the lower the boiling point, because the London forces or van der Waals forces will be weaker. Okay, so back to our list. So planning our long answers so that we don't kind of get sidetracked along the way or forget what the question was that we're answering. Next is show you're working clearly. So again, we have this example for the titration question. Everyone's going to be, getting into different habits about how they lay out the question. With titration questions, I always try to lay it out in this kind of table format that has the 3 rows: volume, concentration, and moles, and then the 2 pieces of the 2 reactants that are in our equation, the NaOH and the H2SO4. So at the beginning, we'll start by filling out the pieces of information that we have from the question, and then we can calculate the unknowns from the calculations from the equations that we've learned. So you can see in the way that I've set out this equation, I've said step 1 is volume times concentration. We have the volume here, the concentration there. So we just take those 2 pieces of information and times them together. Then that gives us our moles of NaOH. We want to then work out from that what the moles of H2SO4 is. So that's the step 2, using the molar ratio to work out from 1 moles how many moles of the other one there is. So because it's a 2-to-1 ratio in the equation, we're going to be dividing the number of moles by 2 to get the right number of moles of H2SO4. And now we have the moles of H2SO4, we're trying to find the minimum volume, so that's this bit here, and we can calculate that by doing moles times, moles divided by concentration. So we've got moles divided by concentration, put the 2 things into our calculation here and get our answer in decimeters cubed. Now remember that the question asked us calculate the volume needed in centimeters cubed, because that's what we've got here as a unit. So if we've got the decimeters cubed unit there, we're going to have to times that number by 1,000 to get us the centimeters cubed. So be careful with things like that, with units that are very specific about what units they would like you to see. And remember to convert units where necessary so that you're actually giving the answer that's expected in the question. So show you're working really clearly, make sure that the examiner can follow what you did. If you want to use numbers to show your different steps, that's okay. If you want to just do it in a specific order, then that's okay too. And with this kind of question, if you want to use a table, then that may also help the examiner to see what you're trying to calculate as you go along. Okay. So show you're working clearly, then check your calculations. Now, some people, I think, find it very difficult to check their calculations, because as you go back to the beginning of the calculation, you're basically just following your own working, and it can be really easy to kind of confirm your own working as you go through it. But try to check it with an open mind, or try to check it as if you're checking someone else's work. Be critical as you're checking your calculations to make sure you're not dividing when you should be timesing. That's a really common error, especially when we're converting between units. And also, for example, there are several situations in which you should have a very good idea of how large your answer is expected to be before you actually calculate it and write down the answer. So for example, with relative atomic mass, it's the average mass of all the isotopes of an element. So you're not going to have a relative atomic mass that's lower or higher than any of the isotopic masses of the element. You're going to have an average of somewhere between the lowest and the highest. So double check your calculation to make sure that your answer fits within the region that you would expect your answer to fit in. There are quite a few other examples of this. For example, later on when you're calculating things like Kc. Kc has a value of 1 when your equilibrium position is exactly in the middle. If your equilibrium position is shifted towards the right, then that means that you have more products than you have reactants, and that will give you a Kc of greater than 1. If your equilibrium position is shifted towards the left, that will mean you have more reactants than products, and therefore your answer for Kc will be less than 1. So based on that kind of common sense information, you should be able to sort of conjure up in your head or deduce in your head approximately how large your answer should be, so that once you put everything through a calculator, you're not just blindly writing down an answer. You're writing down an answer that you can confirm mentally in your head is within the region that you expect it to be. So for example, for Kc, we're expecting it to be less than 1, and it is less than 1, so that's great. Another very good example of this is when calculating pH. So if you're calculating the pH of a weak acid, before you've even put pen to paper or numbers into the calculator, you should already know that your weak acid will have a pH of somewhere between 8 and 10. If it's somewhere above 12, then that's a strong acid and you've probably made a mistake somewhere. If your pH turns out to be something like 2 or 3, then that is, sorry, I said a strong acid a minute ago, I meant strong base. If your pH is 2 or 3, then that's going to be a strong acid. So again, if you're trying to calculate the pH of a weak base, you expect it to be somewhere between 8 and 10. So a weak acid would be somewhere between, let's say, 4 and 6, a strong acid between about 0 and 3, and a strong alkali between about 11 and 14. So again, with pH, you're going to have a really good idea, hopefully, before you even put a calculation in the calculator, approximately what you expect this answer to be. And so hopefully when you get your answer out, you can kind of self-check. Do you think you're on the right track, or perhaps you've completely missed something and need to go back to the start again? The last two things that I wanted to mention are, if you have time left at the end, what are you going to do with it? Are you just going to twiddle your thumbs and wait for the clock to go down? Are you going to leave before the end of the exam? Hopefully neither of those two things. Hopefully you know that the best thing to do is to take the time to go back and check your paper. Go all the way back to the beginning and check your answers. Reread the questions, reread your answers. Make sure that if you put yourselves in the shoes of an examiner, they understand what you've written, they can read it, it's legible, they can follow any calculations, or they can follow the logic in your long answer questions. So please try, if you do manage to finish early, please try not to use that extra time at the end in a way that isn't actually moving forward your chances of getting a good mark in the exam. Similarly, if you start worrying that you'll run out of time, like I mentioned briefly earlier, like if, let's say, you're in the multiple choice section and you start to go over the 25 minutes allocated, then I would suggest that you skip those last few questions, because the maximum mark you'll get for a multiple choice is going to be 1 mark. So skip that and go further back towards the end of the paper where there are some long answer questions. Similarly, you might see that there's a long answer question at the end that you have no idea how to start answering. So in that case, you want to be spending more of your time on the questions that you believe that you will be able to get the marks for. Because if you have no idea at all where to start or how to answer a question, then even if you spent 10 minutes trying to work out what you wrote, you may still not get as many marks as if you spent that same amount of time improving another question, or adding in some clarification to a calculation or something like that. So if you start worrying you'll run out of time, try to keep an eye on the clock on a regular basis and try to focus on the questions that you think you'll be able to get the most marks from. Okay, so this was a little bit of a shorter live than perhaps we're used to having. Normally we do stay on for a full hour and we go through practice questions and things like that. But I think in this case, I really just wanted to give you a few tips, practical tips to go into your exams thinking about. We've already been through a bunch of questions over the last several weeks in the lives over the time. So hopefully you can use that information to help you to remember to do these exam tips and techniques. So for now, I'm going to say stop sharing the screen and say thank you very much for joining me. If you did join me, please join Dr. Rusu again on Sunday. He's going to be talking about isomerism, which should be a really useful topic. I know a lot of people get confused about isomerism, how to identify isomers, how will you know how many isomers there are, and looking at different functional groups as well. So do join him on Sunday. That's going to be at 1 o'clock, and I'll see you again next week. Okay, thanks very much for joining and see you again soon. Bye.